Hello class 10th. In the last lecture we have discussed about the lateral displacement and the principle of reversibility. Today we will talk about the real and apparent depth. So for that you might have experienced that when you are lowering inside swimming pool, when you come down inside swimming pool, then the depth which was appearing before entering the swimming pool was not real. The depth appeared from outside the pool, that was called apparent depth, and when you enter in the pool you feel that this is more than the apparent, and that one is called real depth. To understand that, see here, see this. Suppose, as I am taking the example of glass slab, this is the glass slab. I am placing an object O at the bottom. So if you are able to see any object, that is because light falls on the object and that reflects in all direction, and then you receive and you are able to see the object. Same way, suppose the object is just underneath this glass slab and the light is emitting in every direction. I am taking only two rays. One ray which is going straight. The straight ray will go straight without any deviation, because we know that when the light falls normally on any different media, when the light goes from one medium to another normally, so there is no refraction. The light never suffers any refraction. But second ray, I am taking little bit inclined. So first it will go straight up to the interface where there is the medium is changing. Now what will happen? So we have to calculate at this time some angle, because the light is changing what? The medium. So it will deviate from its normal, because this glass is denser medium and the above one is rarer medium. So it will deviate away from the normal. So let's draw a normal there and say the angle of incidence is I. And now what will happen? The light will deviate from its path and it will deviate away from the normal. Now see its path. Now what you will say? When you will see from outside at that point, if you are suppose standing there, and when you will see, means when you will observe this ray, your brain will say the light ray always travel in straight line. Your brain will say the light is always traveling in straight line. So your brain will consider the image of that object image is at point I. But where is the object? At the bottom, where it appears at the position of I. So this I is what? Apparent image of the real object which was lying under the glass slab. So what is real depth here? From the surface, suppose this point be O, this I, this is A. From the point A to the point O, means OA, this distance will be called real depth. And from A to I, this distance will be called apparent depth. And in your syllabus, the proof is not there. In class 12, there is a proof. So if you want to see the proof, you can see in my videos. There is that how to prove. But here, only you have to remember what? The ratio of real depth to the apparent depth is the refractive index of this medium. Here it is, I am taking glass, so that will be the refractive index of the glass, or any medium you can take. What you have to remember, real depth upon apparent depth is refractive index. Clear? In this diagram again, the A to O, real depth, the A to I, apparent depth. But what is called distance I to O? This distance I to O is called lateral shift or normal displacement. In question, it is written that if the image is raised by or rises by, so what is given? This shift is given. So I will show some question which is based on this also. One question is also there. It was asked in the board examination also, that if it is written the image shifted by, raised by, risen by, if these words comes, means that is IO distance is given. That is what? Normal displacement or lateral shift. So here let's see the equation. The refractive index mu is equal to what? Real depth for apparent depth. So remember this equation. Based on this equation, There are many numericals. Now next topic is some simple effect of refraction. So you might have been observed that while you are putting one pencil inside a glass of water, when you see from a side of that, you will have you have an experience that the pencil appears bent. Why? Because when the pencil gets inside, there is apparent image forms, and the apparent image is little bit at shorter distance. See the example. See in this diagram. In this diagram you can see when pencil was entering inside the water tub, or you can say a glass. So in the starting, if I'm talking about the real position, so straight it is. But the rays, means the light refracted from the pencil outside this tub, so it will go straight first, but due to the changing medium it will bend, and when we will observe from that point, we will observe somewhere here, but at little shorter distance. So that shorter distance, because of that shorter distance, the edge of the pencil appears there. But this is not about only edge of the pencil. Every point of the pencil which is inside the water will appear to be there. When you will join all the points, you will see what? The image of the pencil is bent in the upside. This is the first case, or the first example, or the effect of the refraction. The second example, the second effect of refraction is the bottom of the glass filled with water appears shifted up. For that, I want to show you my own demo. Let's see. For that, I have placed this glass inclined toward the camera, and this is the coin I'm going to place inside. See here. Now you can see the image from this side, but I'm talking about this front image from the upper side. So you can say that this is the bottom here. The exact bottom is this, that you can see where the pen edge is there. So that is the bottom of this glass, and here the coin is placed just here. So if I'll pour some water inside, so what will happen? The image of the coin will shift up, and you will be able to see the coin clearly when I will pour some water. So let's pour water and see clearly. So here you can see first now the bottom of the glass is now able to visible. You have able for you, that is visible to you right now. The bottom of the glass here it right now. Now this is the time for the coin also. Now see, the bottom is now very much clear. Further, now see here, this is the coin here, the bottom. This is the bottom of the coin, but now you are able to see the first part of the coin. On filling some more water, now you can see the coin. This coin was not visible in starting. After filling water inside, the coin's image is shifted up and up and up, and now it is visible. This image, whatever you are seeing, this is called the apparent image. Now further, now I think you are able to see the complete coin inside the glass, and with coin also the bottom of the glass. See this image is the bottom of the glass. Why? Because I have poured some water, so this shifted the image. Again see, again on removing the water, the coin is not visible. Again I will show you. Let the bubbles go out. See the coin and the bottom as well. The coin is at different place. Now it's at bottom. So this shows what? The bottom shifts up due to this refraction. The next example is the twinkling of stars. I don't know you have seen or not. The stars, some stars, not every star, some stars twinkling in the sky. Why this phenomenon is happening? For that, see here. When you see the sky, suppose from the sky to the earth, the different layer of air. Why different layer? Because the hot air will go up and the cold air will be stay down because of the density. So when star emits its light, so the light comes first straight up to the atmosphere. When it enters in the atmosphere, so there are different layers of the air. Different layer means different densities of the air. Different densities means when the light goes from denser to rarer, it bends away from the normal. So the light ray comes not straight, it bends again and again and again because of the different layers. And when we receive this ray, what we will observe? Our brain will observe that the light ray always comes straight. So we will feel at the position of the star, we will feel that the position of the star is at different place, but the wind will always blowing, it will not be always at rest. So when wind blows, the density changes. Since the density changes, so refraction changes. Since refraction changes, so position of the star changes. So sometimes here, sometimes here, sometimes here. So this, because of this changing position of the star at very close to the original position, so we feel that the star is twinkling because of the changing its position. Sometimes here, 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 or here. So we feel that the star is twinkling. Now you might thinking that if the stars can twinkle, why don't the planet? Because of the huge size of the planet, the shift in the image is very small, and the star is very much far distance than the planets also. So that is why the shift in the image of the planet is so little that our eye cannot recognize the changing position. So that's why it's not twinkling. Second thing, the star is a luminous body, but the planets are not luminous, they are non-luminous bodies. Next point is, why does the sun appear bigger during sunset and sunrise time? See here, during sunset and sunrise time, the ray of the sun goes through the maximum thickness of the atmosphere. Since the ray is going through the maximum thickness of the atmosphere, so maximum refraction is there. Since the maximum refraction, the image of the sun, apparent image, comes closer, because we have seen in the when I was putting the pencil inside the water, inside the glass of water, the apparent image is coming closer to the observer. That is why it was appeared bent. Same way here also. At sunset and sunrise time, the person will feel the apparent image little more closer than the original position. That is why the image which comes closer to your eye appears big. For example, the size of the hand, whatever the size, at this time the image will be bigger. When the object comes closer to your eye, the size of the image becomes bigger. Same way in this also. During sunset and sunrise time, the light goes to the maximum thickness of the atmosphere, maximum refraction. So the image comes closer to the observer, and the closer image means bigger image. That is why it feels the bigger size of the image. And what about at the noon time? At the noon time, sun is just above our eye. So at that time, the ray will go straight to the earth, no refraction. At noon time, if you are seeing any sun, sorry, not any sun, at noon time if you are seeing the sun, whatever the size of the sun, that is the real image of the sun. I am ending this lecture. In the next lecture, we will discuss about the images formed, multiple images formed through a thick glass mirror and few numericals. Till then, be safe, take care, and thank you.